Now the first thing to keep in mind is that a Linux user is not an SE Linux user, and an SE Linux user in turn is also not a Linux user. In fact, when you run SE Linux in targeted policy, like most of us do, every regular Linux user is automatically mapped to the unconfined user. And a Linux user can only be mapped to a single SE Linux user. Now next to this unconfined user, there's also a system user or system_u. Kernel processes and important daemons like SSHD, crond and others are mapped to this system user. Now, next to the unconfined user and the system user, there are some more Linux users. But by default, if you run SE Linux targeted, then you will only see mappings to system U and unconfined U. This basically means that the users that are mapped to the unconfined user will not be restricted by SE Linux. Of course, with other security settings that take place before SE Linux steps in, you can control access rights. But SE Linux does not restrict these unconfined users. That's why they're called unconfined. So when we run se-info-u, it will show us the other SE Linux users. And next to the user, we can of course also have a look at the role and the type for these users. So if we run ID capital Z, it tells us that we are an unconfined user, and we have an unconfined role and an unconfined type. And it's the type that provides the access rights. So in fact, we're not confined. If we want to know what the cron daemon looks like, which is one of these system daemons, then we see that it's of the system user, system role, and cron d type. So obviously the cron daemon runs in the cron type domain. Remember, processes run in different domains to restrict them. Now let's see how this user mapping works. Like this, we create a user called 1, and when we su to the user, we see that it's unconfined from beginning to the end. Now to keep things simple, we're going to pick two different SE Linux users and see how permissions can differ when you map them to a different SE Linux user. So again, a Linux user will always be mapped to an SE Linux user, and you can choose. And we see we have the guest user and we have the user, so to say. The unconfined type allows su and sudo, and it also allows networking. But the user type does not allow su and also not sudo, but it does allow networking. And the guest type will deny all three. Now let's have a look at that. Now next to user 1, we also create user 2 and user 3. And we map them to a different SE Linux user. 2 will be mapped to user and 3 will be mapped to guest. Now let's list them. So we run semanage login-l and we see that we have those two users. What we don't see is user 1, and that's because it's a default user, so it's mapped to the unconfined domain by default. And that's so for all the other users, we won't see them. But user 2 and user 3 are mapped to user and to guest, respectively. Now let's give both users a password. So we'll both give them the password pass2. And then when we SSH into localhost as user 2 and we try to run the sudo command, for example, it will block us. So permission is denied. But if we want to ping, for example, Google, then we do get a reply. So we can access the network. And then we exit, obviously, and we connect as user 3 to localhost. And we run sudo. We get an error message. We run ping. We're also not allowed to access the network. So we're completely blocked. And finally, we can also change the mapping of existing users. So for example, we can change the mapping of user 1 to the guest environment. So we use semanage login to change that mapping. So we SSH into localhost as user 1. We check our mapping and we see that we're mapped to guest U. And finally, to clean everything up, we have to remove both the Linux user and the mapping. So let's quickly delete the users. Mind you, this only deletes the user, it does not remove the mapping. So we get rid of user 1, user 2 and user 3. And we list the mappings again, and we see that we still have the mappings. And when we delete the mapping for user 1, it very nicely tells us that there are more mappings that we should clean up because these users are also no longer in the password file. So let's do that. So we actually clean up not just the users, but also the mappings. So we run the listing for the last time, and we see we're back to where we started, and we're done.